This video is on difference of two squares. It's part 1.6 of how to do the algebra series of videos or lessons, and we've just done a video, or just if you worked through the last video, you just worked out how to factorize quadratic equations, which are of the form ax squared plus bx plus c, and we only looked at quadratics where a equals 1, so they're the simple ones, the straightforward ones, and that's grade B. In all the examples we looked at, b was not 0. If it is 0, we get something of the form x squared plus c, because that bit's 0, and if we just consider a to be 1 to begin with. Okay. Now, if that actually turns out to be something like this, where c is a negative number, and negative square number, then we have a special case, a very important special case, which is called the difference of two squares. Because x squared take away 4, well, 4 is a square number which can be written as 2 squared. So this is the difference of two square numbers. X squared take away 2 squared, or x squared take away 4. Now if you ever see a problem like that, or that in any problems, it's well worth factorizing it in the difference of two square form. Now before we go there, let's just remind ourselves of a very simple thing that we worked out in the previous video, that if you've got x plus a and you multiply that x plus b, multiply that out, you get x squared plus a plus b lots of x plus ab. So what's that saying is, if you multiply out, you can write it out quickly, or if you're factorizing, then you work out these two numbers here, the a and the b, add together to make the coefficient of x, the number in front of x, and they multiply together to make the constant at the end. Now we can use that idea when we're factorizing quadratics where they've got a difference of two squares, because to begin with it might not look like it's got anything in common, and it doesn't look like our normal quadratic, which would have, say, 2x in the middle or something like that. But in this case it does work. I mean, if we're looking for two numbers that multiply together to give negative 4 and add together to give, well, how many x's do we have in here? That's a question for you. Okay, well, how many x's do we have in here? The answer is no x's. I mean, you might say that's an x, but that's not. That's an x squared. So there's no x's. So we could have written this as x squared plus no x plus 4. But we don't, because we'd have to write everything else in here as well where there's none of, and that would take forever. So, but just for illustrative purposes here, we're going to put it in as 0x. Now, looking at that then, we're looking for two numbers that multiply together to give negative 4. That could be negative 1 and 4, 1 and negative 4, and negative 2 and 2. And now, which pair of those, when you add them together, gives 0? Well, it's this pair here. So this factorizes to x plus 2, x minus 2. And in fact, it's the same true if any of those numbers are square numbers. So let's just call that x squared minus a squared. Okay. So we're looking for two numbers that multiply to give minus a squared, and we're looking for two numbers that add together to give 0. So those numbers are minus a and an a, or an a and a minus a, which are both the same. So this factorizes to x plus a, x minus a. So it's a very important little fact in mathematics, the difference of two squares. It comes up a lot. If you ever see two square numbers, x squared minus 25 for instance, that factorizes straight away to x plus 5, x minus 5. X squared minus 36 factorizes to x plus 6, x minus 6. you do the next one. X squared minus 49. X squared minus 1. Do those two, please. Pause the video, finish those. Okay, well, we've got x plus 7, x minus 7. Well, you could have those the other way around as well. You could have x minus 7 first, followed by x plus 7. And this one's forgotten often by students because they forget that negative 1, also 1 is a square number. So that's actually x plus 1, x minus 1. Okay, so if you ever see difference of two squares, it's well worth factorising it, and quite a lot of times that will help us when we're simplifying algebraic fractions, for instance. Just before we finish the video though, you can actually have questions like this, because this is also a square number. You can write this as, if you wanted to, 2x all squared minus 5 squared. So the difference of two square numbers this time. So this time it's going to be 2x minus 5 or plus 5 and 2x minus 5. Okay, so both terms can be square numbers. Now remember, you're meant to know your first 15 square numbers, so don't be put off if it's something like the following: 9x squared minus 196. In fact, you see if you can work out that answer, please. Okay, well, the 9x squared is square rooted is 3x. So it's 3x, and the 196 square rooted is 14. So it simplifies to that. So that's the difference of two squares. Very important. It's only a short video, but it's well worth looking out for when you are doing harder problems. These difference of two squares come up a lot on grade A simplifying fraction questions.